Welcome to my video about flexible visual summaries of high-dimensional data using hierarchically aggregated data subsets. My name is David Pfahler and I'm from the VWIS Research Center. First, let's talk about the challenge of high-dimensional data. Data is acquired at a very high pace. For example, the installation of photovoltaic plants are clustered in farms, cities, countries, or even whole areas like Europe. Every photovoltaic plant acquires time series for their power production values, but also measures meteorological values like radiation, wind speed, air pressure, temperature, and many more. A lot of sensors, which means a lot of data. A lot of data means many data columns and data rows. The key idea of my approach to visualize these high-dimensional data sets is to utilize the meta-information of the data table. Here, a small version of this big data table is shown. Categorical meta-information on the columns are, for example, sensor types or the location of the sensor. Meta-information on the rows are, for example, time intervals like the year of the acquired data record. The data table is subdivided by the categories of a meta-information, for example, the sensor type or the year, into smaller data chunks. Then, statistical properties are calculated of these data chunks, for example, the arithmetic mean. Then these properties are encoded into a visual representation. The visual representation of the means of the data attributes are shown in the right column. By combining the data attributes by their sensor type, the visual space can be used more efficiently. A further subdivision by the year increases the underlying data chunks as seen in the mean column. The hierarchical data overview framework supports three different types of statistical properties. Central tendencies, for example the median, are encoded as lines. Dispersion, for example the interquartile range, are encoded as areas. And frequency distributions are encoded as histograms. The combination of the data chunks within one row in the tabular layout is done by superposition or overlaying the visual representations. The hierarchical data overview framework can be explored and tuned by the user by interactively drill down the visual set of rows. Or roll up to combine underlying data chunks. Thank you for your attention.